Chapter number 2, Kinematics. These slides are made especially for the students of O levels who are going to appear in IGCSE, GCE, or Edexcel. But the students of metric, they can also get benefit from these slides. Topics which we are going to cover in this slide are uh, distance, displacement, speed, velocity, acceleration, deceleration, acceleration due to gravity, and free fall of a body. The notes for these slides are available in the description. So subscribe our channel so you can get better knowledge of the subject. Okay, let's start at motion of different objects is motion. Kinematics is actually related to the motion of the objects. So we can observe in our daily life the different objects, for example, a car moving on the road, a plane flying in the sky, a man walking on the road. Everyone have its unique motion, right? Everyone have different type of motion. And in motion, the basic thing is distance and displacement. There is a basic difference between distance and displacement, which is that the distance is a scalar quantity and displacement is a vector quantity. Now, what is a scalar quantity? What is a vector quantity? I'm not going into the details of that. You can, I can just say that displacement is a vector quantity because it has magnitude as well as direction. Okay. Distance is the total length covered by a moving object irrespective of the direction. Displacement is the distance measured in a straight line and in a specific direction. You can have a better understanding, you will have a better understanding on seeing the picture. Now read the definitions again. The distance which is in the blue line is the total length covered by the moving object, irrespective of the direction. And the displacement which is in the red line is the distance measured in a straight line and in a specified direction, that is from A towards B in a straight line. Let me give you another example. For example, in this example, this red color is showing the total distance which is 70 kilometer, and the blue line is the displacement which is 14 kilometer only. So this is the total distance covered in red color, and the blue line is the displacement which is the shortest distance in a straight line. So distance and displacement. Let's move on. Then we have speed. Speed is the rate of change of distance. Speed is also a scalar quantity, right? The formula is the distance moved over time taken. V is equal to d over t. Average speed is the total distance covered by the object divided by the total time. This will give us the average speed. Then we have instantaneous speed. Let me give you an example. For example, you are going on a highway and a policeman stops you, and he says that while you were passing our speed checking camera, at that particular instant your speed was 140 kilometers per hour, right? Which means that you were overspeeding at that particular instant. So your speed at that particular instant is called instantaneous speed, right? The speed at a particular instant is called instantaneous speed. The units, we can derive the units from the formula. The units of the distance are meter. The units of time are seconds. So the units of speed are meter per second. What is the, let's move on. Okay, here we have an example of a car moving with different velocities or speeds. Okay, and now we have an example. An athlete ran a distance of 100 meter d, which is 100 meter, in 9.83 seconds, which is t. We have to calculate v, which is average speed. Okay, so we have the formula total distance covered by total time. So the athlete ran 100 meter divided by 9.83, which gives us 10.2 meter per second. So that was a simple example. Okay, then we have velocity. There's a difference between speed and velocity because speed is a scalar quantity, velocity is a vector quantity. Velocity has direction as well as magnitude. Velocity is the rate of change of displacement, or it is speed in a specified direction. Units of velocity are same as that of speed, but it has an additional thing which is the direction shown by an arrow. Okay, constant velocity, for example, a person is moving with a constant velocity. What does that mean? It means that the speed as well as direction, because we have two things in the velocity. One thing is speed, that is the magnitude, other thing is the direction. If both the things are not changing, if both the things, the speed as well as the direction of a moving object is not changing with time, it is said to be moving with constant velocity or uniform velocity, we can also say it. Okay, acceleration. Now, what is acceleration? For example, an object whose velocity is changing is said to be accelerating. Or, in other words, if the direction or the speed, because as I already told you, we have two things in the velocity, one is the magnitude, other is the direction. If both of these two things or any one of them is changing with respect to time, we will say that the body is accelerating. For example, this text written in the green color, it has an example. It is for the example of a rocket. So you can read it. If an object is moving in a straight line, but the speed is changing, it means the direction is not changing. It's moving in a straight line. It's moving in a straight line, but the its magnitude is changing. Its direction is constant, but magnitude is changing. It means it is accelerating. It's still accelerating, right? We have the text written in the red color. This is for the merry-go-round, right? If the object is moving in a curved path, even with constant speed, it is said to be accelerating. Got it? So we have the formula for the acceleration: change in velocity. This change can be the change in speed or change in direction or change in both. So acceleration has the formula: change in velocity over time. Acceleration is equal to delta v over t. The units can be derived from the formula, which are meter per second scale. Okay, then we have deceleration. Deceleration is negative acceleration, right? When the speed of the body is decreasing, it is said to be decelerating. For example, a car decelerates when brakes are applied, right? So when the speed of the body is decreasing, it is said to be decelerating. Okay, then we have some graphs. The first important graph is between distance and time, in which the distance is taken on the y-axis and time is taken on x-axis. We have two graphs. Let's compare them. For example, in the first graph, the slope is very steep, which means that the body has covered more distance in the same time, as compared to the second graph, in which the body has covered lesser distance in the same time. So it means that in the first graph, the speed of the body is more as compared to the speed of the body in the second graph. Okay, in this third graph, the body is not moving. No distance is covered. Body is at rest. Speed is zero, right? So you can say anything. The speed is zero, body is stationary, body is at rest, no distance covered in the third graph. Okay. Now we have some more graphs. Let's have practice of these graphs. In the first graph, it is no distance covered, body is stationary. Second graph, in the second graph, we have two objects moving at different speeds. In the third graph, we have an object moving at constant velocity. The straight line shows that the body is moving with constant velocity. Straight inclined line. The straight inclined line shows that the body is moving with constant velocity. And then the horizontal line, it shows that the body has come to rest. So the third graph, object moves with uniform velocity and then comes to rest. In the fourth graph, the object moves to a point and comes back to its original position. Again, in the fourth graph, the body is moving with uniform velocity because it's a straight inclined line. In the fourth graph, it is a curved line, which means that the body is moving with increasing velocity. The velocity is increasing at every particular second. At every passing second, the velocity is increasing. Okay. Then we have another important graph between velocity and time. This red line, this green line, the first green, we have green line, which is showing that the velocity is increasing, which means that the body is accelerating, right? Uniform acceleration, it's moving with uniform acceleration. Uniform acceleration means its velocity is increasing at the straight line. The green line is straight inclined line. That is why we will say that its acceleration is uniform. Okay, then we have the red line in which no increase in the speed or no decrease or not change, no change in the velocity of the object, which means the body is not accelerating, no acceleration, zero acceleration, right? Uniform velocity, no change in the velocity, zero acceleration. The third line, it's very interesting, the purple one. In this purple line, the velocity of the body is increasing, but it is increasing at an increasing rate. What does that mean? It means that, for example, in first 2 seconds, its velocity changed from 0 to 10 meter per second, and in next 2 seconds, its velocity changed from 10 meter per second to 40 meter per second. It means that its velocity is changing, but not changing at a constant rate. It is changing at an increasing rate, right? This is called increasing acceleration, right? We have another interesting thing which is called decreasing acceleration. It is different from deceleration. In decreasing acceleration, the velocity of the body is still increasing, but at a decreasing rate. Whereas in deceleration, the velocity of the body decreases. Let me explain it to you again. For example, a car is moving. In first 2 seconds, its velocity changes from 0 to 40 meter per second. And in next 2 seconds, its velocity changes from 40 to 50 meter per second. It means that its velocity is increasing, but increasing at a decreasing rate. Whereas in this fourth case, which is the blue line, deceleration, the velocity of the body is decreasing from 50 to 40 to 30 to 20 to 10 to 0, right? So velocity is decreasing at a constant rate. I hope you got it. Now it's the revision of the graph. The slope of this is the distance time graph. The slope of the distance time graph gives us the speed. Steeper the slope, more the speed. Shallower the slope, lesser the speed. These are the formulas. This is the graph for velocity and acceleration. It's a revision of the graph for velocity and acceleration. Slope of the graph gives us the acceleration. Slope of this graph gives us acceleration. Area under this graph gives us the distance. This is very important thing, that the area of velocity time graph, area under the velocity time graph gives us the distance. Okay, then we have steeper the slope, more the acceleration. Shallower the slope, lesser will be the acceleration. And there is the formula for the velocity and acceleration is related to velocity. Okay. So here we have a question in which we have to find the distance with the help of velocity time graph. So what we will do, we will find the area under this red line, which will become a triangle. So the area of the triangle we know is equal to 1 over 2 into base into height. So the base is 5 seconds, height is 50 meter per second. So 5 multiplied by 50 divided by 2, that will be equal to 125 meters. So the area under the velocity time graph gives us the distance. Okay, then we have the last topic, which is free fall or acceleration due to gravity. For example, an object or a person is falling freely. When a body falls freely from a height, it accelerates, right? Its velocity changes. Acceleration of a freely falling body near the earth is called acceleration due to gravity. It's denoted by g and its value is 10 meter per second, which is constant near 1 kilometer or around the earth. If we go away from 1 kilometer, that is into the space, towards the space, the acceleration due to gravity will decrease, right? Because the attractive force of the earth will decrease as we will go away from the earth. Okay. There was a scientist in 17th century, his name was Galileo, right? He observed that if we drop a large stone and a small pebble from the same height at the same time, they have the same acceleration due to gravity regardless of the mass and the size. For example, uh, if we drop a metal ball and a feather from a height at the same time, what do you think? What do you people think? Which thing will reach the ground first? Obviously, all of us will say that the ball, as it is heavier, right, it will reach the ground first. It's a common observation that the feather will take much more time as compared to the ball. But this will not be the case if we do this experiment in vacuum. Now look at the video, right? If we drop the two things simultaneously at the same time, they will reach the ground at the same time. So because we are doing this experiment in vacuum, there is no air resistance. So Galileo's experiment in 17th century, that is verified from here, that the acceleration due to gravity is not affected by the mass or the size of the object, right? So acceleration of a freely falling object does not depend upon the mass or size. The velocity of the two objects under gravity increases by 10 meter per second in every second. Both objects undergo constant acceleration of 10 meter per second square, because in this vacuum there is no air, so that is why both the objects reaches the floor at the same time. Okay, then let's look at the effects of air resistance. For example, you are moving on a bike or you are going in a car and you take your hand out of the window of the car, the air will brush against you, right? That brushing air is called air resistance, right? Air resistance is a frictional force. It has the following characteristic. The first characteristic is that it always opposes the motion of the object. If you are moving in the forward direction, air resistance will be in the backward direction. Second point, it increases with the speed of the object. If the speed of the object is increasing, you can observe it while sitting on a bike, that when you will increase the speed of the of your bike, the air resistance will increase. Okay. The third point is it increases with the surface area. For example, is in the case of a parachute, when you increases the surface of area of the parachute, the air resistance increases. Right? Okay. Okay, as you are coming down and you open the parachute, the air resistance increases. Your speed is increasing, the air resistance is increasing. A point will reach when the upward air resistance will be equal to downward weight of the object of the person. At that particular instant, when the upward force becomes equal to the downward force, which means that the resultant force is zero, and the body will start moving with zero acceleration. Because the resultant force is zero, body will move with zero acceleration. It means that the body will start moving with when the body is moving with zero acceleration, it means it is moving with uniform velocity, and that uniform velocity is known as terminal velocity. Right, now you can read the definition. When the air resistance becomes equal to the weight of the falling object, the object starts traveling with a constant speed called terminal speed. This means that the object has zero acceleration. If the object falls through a short distance, it may not reach the terminal velocity. Why? Because the upward force and the downward force, does not get much time to become equal, right? That is why in a short distance, when a body falls through a short distance, it may not reach the terminal velocity because it does not get adequate time to get equal. Okay, I think that's end of the uh, topic. These are the all the topics covered. I hope you have a good understanding of the topic, and you can get the notes from the description. Okay, take care.